So we got this situation to handle. Let f of x be a polynomial of degree 5 with leading coefficient unity such that f of 1 equals 5, f of 2 equals 4, f of 3 equals 3, f of 4 equals 2, and f of 5 equals 1. Then the value of f of 6 is. Now, the point is, before solving this question, you need to find out who is f of x. As they have mentioned that it is of degree 5, so we can write down 5 degree polynomial ax power 5 plus bx power 4 plus cx cube plus dx square plus ex plus f. Also, these guys have mentioned that the leading coefficient is unity. So if they will tell you that leading coefficient is unity or it's a monic polynomial, both means the same. This means the leading coefficient would be 1. So you don't have problem with A. Now you have to solve this equation for B, C, D, E and F, which are 5. So there are 5 arbitrary constant involved, and to answer that thing they have given you 5 situations. So for that you have to resolve, you will get 5 equation. You have to solve those 5 equation for 5 variables, that is B, C, D, E and F, and then you will be getting f of x, and then you have to respond accordingly. But I find this method to be bit lengthy. Why? Because I have to substitute 5 and then I have to handle 5 power 5, 5 power 4, 5 power 3, 5 power 2. It is very big numbers. Okay, so instead of going through this method, I will suggest you guys to go through some other approach so that you can minimize the timing and the approach should be effective. Now look at this. Suppose that I have given you this question. You have to divide by 3. So you will get this. Correct? So suppose that this 7 is the polynomial f of x. So can you write down this 7 in different form? You can write down 3 into 2 plus the remainder. So remainder theorem you are applying. So can I write p of x, q of x plus remainder r of x? Why I am telling like look at this. Also you know that this would be a polynomial, this would be a polynomial. So if I will multiply, again we will get a polynomial, no? So instead of writing two things, can we write directly q of x plus r of x? Now, you know that in class 9th or 10th, you guys have studied remainder theorem. So f of 1 will give you the same remainder if you will divide the polynomial by x minus 1, correct? You will get the same remainder if you will divide the polynomial by x minus 2, x minus 3, x minus 4. Correct? Now I am trying to connect. Look at this. These are the remainder that we have studied in class 9th and 10th. Now, so we have to establish relationship between the remainders. So if you'll observe, the numbers are 5, 4, 3, 2, 1. So if you will observe, you will find these numbers to be in AP. So whenever there is requirement of writing uh, the general form of the AP, you should go with dn plus or minus something. Okay, now who is D? D is the common difference. So what is the common difference? I'll be writing an. I'll like common difference is 4 minus 5 is minus 1. So minus n. Now the first value of n is 1 because you will get like first term. Okay, so first value of n is 1, but the first term is 5. Now if you will replace n with 1, you will have minus 1. Now according to us we got minus 1, but according to them we should get plus of 5. So what we should do with minus 1 to make it plus of 5? We should add 6. Now you understood plus or minus meaning. So this is the remainder. Now let's replace this remainder with our remainder. You know that here the variable is n, but we have to write down the polynomial in x, so we will be writing 6 minus x. So this is your remainder. Now look at this, how we will approach. So the point is, first I will use the first point. I will replace x with 1. So f of 1 is equal to q of 1 plus 5. You know that f of 1 is 5. So 5 gone. Can I say that q of 1 will become 0? Means what I am trying to do, I feel that if we can find out who is q of x, we can manage who is f of x. है ना? Because this is known. And if we know who is q of x, we can manage everything, no? So this is my idea. So you got q of 1 as 0. Similarly, you will replace x with 2. So you will get q of 2 equals to 0. Similarly, you will replace x with 3. So you will get q of 3 equals to 0. Similarly, replace x with 4. So q of 4 equals to 0. Similarly, q of 5 equals to 0. Now, you know that we were trying to approach q of x, but look at this. We don't know who is q of x, but we exactly know that q of x is a polynomial whose zeros are 1, 2, 3, 4 and 5. Because at these points, the q of x becomes 0. So 1, 2, 3, 4, 5 becomes the 0 of the polynomial q of x. Now, can I update our function p like f of x as x minus 1, x minus 2, x minus 3, x minus 4, x minus 5 and then 6 minus x. Is that okay? So this is your polynomial. I will update little bit more, but for time being this is final. Now if you'll observe, now just focus on f of x again. You know that f of x is a 5-degree polynomial. So look at this, how many components do you have? 1, 2, 3, 4, 5. So if these 5 things will be multiplied, you will have 5-degree polynomial for sure. So first idea is correct. With leading coefficient 1. So you know that x will be multiplied by x, it will become x square, then x cube, then x power 4, then x power 5. So it is 5-degree polynomial and the coefficient is 1 only. So this is our final f of x. Now we guys have to calculate who is f6, as we have already calculated who is f of x. So we have to calculate who is f of 6. So replace x with 6. So 6 minus 1 is 5, 6 minus 2 is 4, 6 minus 3 is 3, 6 minus 4 is 2, 6 minus 5 is 1 and 6 minus 6 is 0. So you know that it is 5 factorial, which is 120. Therefore the required value is 120. I hope you guys got the idea, you guys got the approach, and I wish you guys can handle similar situations as well. Okay.